Hey everyone, welcome back to the channel. I hope you guys are doing all pretty well. So we will see today's daily challenge on Leetcode and we will try to solve it together. And so today's challenge is a pretty difficult problem. So yeah, I will request you to please stay focused till the end. Otherwise, there might be difficulty in understanding. And if you still have any doubt, please ask me in the comment section. I will try to use a simple mathematics approach. Okay, I will try to keep the solution as simple as possible using only maths, and I will try to ignore any graph algorithms or whatever is shown in the editorial. If you just look at that, I feel that is a bit complicated, but yeah, you can try for those. But yeah, I will go through the mathematics approach, a simple O of n solution, and the space complexity will also be very large, very less. Okay, so yeah, not much difficult, and yeah, let's see the problem, and then we will discuss about this approaches and all. Okay, so yeah, time complexity can also be, I guess, less than yeah, once to the string we need to iterate. So yeah, anyways, yeah, whatever be the case, we will discuss. So let's see the problem statement. You are given a binary string s and an integer k. In one operation, you must choose exactly k different indices and flip each 0 to 1 and each 1 to 0. Return the minimum number of operations required to make all the characters in the string equal to 1. If it is not possible, return -1. So what they are asking to do is that you need to make this string consisting of all ones, and at a time you can flip k number of strings, okay, k number of characters. So if you flip this 0, it will become 111, and using just one operation you have converted the string with all ones. Okay, so now if you want to see, whenever you need to flip, for this example, you need to flip three characters. They can be belonging to any indices. So you see, at first they flipped zeroth index, first index, okay, and third index. If they flip all these, what will this become? One will become zero, will become one, and these two ones will become zeros. So 1 0 0 0 you will get, and then again you can flip the last three bits into one, and in just two number of operations, you were able to convert this. Okay, and you see for this example, using two, since you need to always flip two bits, and there is only 1 0, every time you will end up in getting 1 0 always. Okay, so if you even if you flip the two ones, you will get three zeros. Then again whatever you do, one or three zeros will be there, and you can never convert to all ones. So that's how the you need to output -1. So yeah, that is all about the problem statement. I hope at least the problem statement is now very much clear to you, and I will request you to definitely try it on your own before continuing to watch the video. Okay, yeah, assuming you have tried the problem, yeah, we will go forward. Uh, so we will see this as some string. So let's say we have some string consisting of ones and zeros. Okay, and we need to flip some zeros or maybe ones also. Uh, and what you need to do is that convert this string to something like this, all ones. Okay, for that, one thing is very obvious. What is obvious is that you need to flip every one even number of times. Okay, you need to flip every one even number of times. Even number. Okay, you need to flip every zero odd number of times. I hope you do understand what I'm trying to say. If you flip this zero one time, you get one. If you flip this zero three times, one, two, three, you get again one. So you need to convert to all ones, right? So once you need to flip even number of times, and all the zeros you need to flip odd number of times. Okay, this much observation should be at first very clear to you. And another thing which you should be able to observe is that let's consider as the number of operations to be I. Okay, so this is the number of operations I took to convert this string to this string. Okay, I number of operations, and I want the minimum number of operations. So I want some inequality of I. Okay. I want, if I want to solve it some using some mathematics, I want some inequalities on I, because I want the minimum I. So I want something like this: I greater than equal to something. Okay. And if you see, if I get multiple such inequalities, I will combine those. But if I get I greater than equal to something, this something can be our answer. Okay. I hope this much you do understand. Okay. So yeah, I need an inequality on I. This is also very clear. Okay. One thing is that what is the total number of flips that you are doing? Total flips that you are doing. Total sum of all flips. Sum of all flips. So let's say in this jth index, you do some number of flips. Let's call it aj. Okay. So aj just represent at the jth index how many flips you do. Okay, just you think like this. So total sum of all is nothing but summation aj. I hope you do understand that will be nothing but I into k. I into k. Why? Because you perform I number of operations, and in each operation you perform k flips. So in one operation, if you perform k flips, quite obviously in I operations you perform I into k flips. Okay. So total sum of all flips is this. Okay. Now let us see how can this thing vary. I need again, my aim is to get an inequality on I, right? So yeah, my aim is this: get some inequality on I. So uh, let's try to consider what can be the maximum sum. See, so total sum of all flips is I into k. Okay. What can be the maximum and minimum such flips? Okay. Minimum such sum. Okay. So if you consider the case of minimum sum, it will be very simple actually. So let's see. As I told you, we have this number and some things we have, and you want to convert to all ones. So as I told you, you have to flip this one even number of times. You have to flip this zero an odd number of times. Okay. Okay. This is very clear. Now I want to find the and I know that total flips, total sum of all flips is I into k. I want to find the minimum such value of this total number of flips. So you can tell me that, hey, if you are flipping this even number of times, consider the smallest even number, consider the smallest odd number for this. Okay. So yeah, so if you want to flip the minimum number of times to convert this to all ones, you will not flip the one at all. That is, you will flip it zero number of times. You will flip the zero one time only, an odd number of time. So in this way, 0 plus 0 plus 1 plus again 0 for this one, again plus 1 will give you something. What will it give you? It is nothing but the number of zeros. Okay, it is nothing but the number of zeros, or I can just write zeros. So the total, the minimum sum of flips will be this, at least this. Okay, at least. I'm not telling that, hey, in every k you are telling, you might tell me that, hey, every time we need to select all the k bits and flip all of them. Okay, then how are you telling that this will be the minimum? But yeah, this is not the minimum. I'm saying that at least this many should be there. Okay, at least the number of zeros, at least this many should be there. So what I'm essentially telling is that minimum sum of flips, minimum sum of flips, okay, that will be nothing but number of zeros count that we can count easily by iterating through the string, right? And you see the total flips, is this. So essentially you want to tell that total flips will be greater than equal to minimum sum, so total will be 0. Okay. And if you try to solve an inequality, see, again you must remember that you want an inequality on I. Okay. So if you try to get an inequality on I for this, what will you end up? This implies nothing but ceil value of zeros by k. I hope you are not getting confused at all. See, why we use ceil value? So let's say 0 was 5 or k was 2 or something, and you want the see the ranges of I, right? So if you solve it normally, zeros by k, it will be 2.5. But since these are all integers, I cannot be 2.5, so I has to be greater than that. That is the seal value of this. So 3 and all, 3 and above, 3 and above, right? So that's why you use the seal value, and I hope you are not getting at all confused by this. Okay, you should not. This is just basic integer division. You must have done it in your some junior classes. Okay, yeah, I hope this is very clear. I should be greater than seal of zeros by k. Now, is this inequality sufficient? Definitely not. Definitely not. You just found out the minimum flips, and there can be something more. There can be something more. Okay, so let's find the maximum flips. We found the minimum flips. Let's see for maximum flip. Okay, max sum of flips. So you are essentially calculating the max of summation of a of j. Yeah, that's just the representation and nothing else. So let's go. And earlier we tried to see the minimum such thing, and this time I will see the maximum such thing. So again, you have this number with you. Okay, and let's consider some cases now. Now this maximum sum depends on two cases. If you see, when I is even, when I is even. So you see, you are basically, the total number of flips is nothing but I into k. Okay, so there can be two cases, when I is even or when I is odd. Okay, so yeah, obviously there can be these two cases. So if I, that is the total number of operations which you are doing, that is even, what will happen if that is even? Okay, so uh, you can tell me that in ones I need to do an even number of operations, in zeros I need to do an odd number of operations. So therefore, when I is even, I will do I operations on one, and just less than, see, I is the maximum operation which I have already done. Okay, so the odd number which is less than I, if I is even, is I minus 1, right? So I minus 1 operation. So you can tell me, for getting the maximum sum, see, for getting the minimum sum, what did I do? I did 0 operations, a 0 number of flips, and odd, for odd I did 1 number of flips. For getting the max, when I is even, I will try to flip all the ones by I even number of times, and I will try to flip all the zeros by I minus 1. I'm not telling that definitely I will flip, but this is some criteria, like to find the max sum. Okay, so I hope you do realize max sum will be nothing but, uh, now to calculate the total number of flips. So number of ones, so number of ones which you have, so number of ones into I, this many flips, plus number of zeros into I minus 1. Okay, you can rearrange this to write ones plus zeros into I minus zeros. Okay, I hope this is not creating any kind of confusion. And this is nothing but 1 plus 0 is what? N, the length of the string, n into I minus zeros. Now this maximum sum, this should be less than or equal to I into k. See, the total flips is this. The maximum sum of flips, this should be less than or equal to this, because this is the maximum value, quite obviously, right? So you can again rearrange this to write n minus k into I should be less than equals to zeros. Okay. So again the same thing. I is so I hope you do understand. This will be greater. Okay, so this is, since this is the maximum value, this will be, I wrote the inequality wrong here. If you just try to see, yeah, since this is the maximum value, this will be greater than equal to this. Okay, again, so yeah, this is greater than equal to this, and I therefore will be greater than equal to seal of zeros by n minus k. Okay, see, we are getting more inequalities. we are getting more inequalities. So, but here I must be odd. That we will take care later. But you see, this is something which is always true. This is something which has to be always true, and this is something which is true when I is odd. Okay, so please remember these small things. Something which is always true. Okay, and something which is true when I is odd. True when I is odd. Or I is odd or even. What did I take? Yeah, I took I is even, right? This is something which is true when I is even. Okay, so and for I, if I is even, you see, one thing you must notice that, see, in the number you had some zeros. Essentially you need to flip the zeros only. Okay, odd number of times, right? So total number of operations which you are doing, I into k, this number of flips, that parity of that flip should be equal to the parity of the number of zeros, because all the zeros must be converted to 1. So essentially what I'm telling is that I into k module 2 should be equals to zeros module 2. Okay, I hope this is you easily understood this, I hope. Okay, because the number of zeros, if it is odd, I need to flip an odd number of times. Okay, I need to flip all the zeros to 1. So this number of flips should be, so that parity should be equal to the parity of 0. Now I'm telling that I is even. Okay, now when I is even, I into k is always an even. Then the condition turns out, the same condition turns out that zeros must be even. Zeros module 2 must be equal to 0. So I will write a statement, if zeros module 2 equal to 0, then do this. Okay, then calculate this odd I. So I hope you do understand the criteria and there is no confusion. Okay, now comes the case when I is odd. Okay, so let's see. I am again, what I'm doing, I'm calculating maximum when I is odd. Maximum I'm calculating. Okay, so yeah, I will just calculate for the case when I is odd and when I is even, and I will just take the maximum of these two. See, these two inequalities, if I get two inequalities which says that I greater than equal to a1, another inequality which says that I greater than equal to a2, then what I should write is that I should be, if I want to try the minimum number of operations, I should tell that I should be max of a1 a2. I hope these things you know. Yeah, so maximum, how will I calculate the maximum now? Again, let me write this. We have this series of zeros and ones, and now I is odd. So you want to flip these zeros and odd number of times. So you want to flip these zeros and I number of times, and you want to flip this ones and I minus one number of times. So very easily, you can just tell me the maximum sum will be nothing but ones into I minus 1 plus zeros into I. Okay, now again, this is maximum sum. This should be greater than or equal to I into k. Okay, so again, I hope you can club these things to get I into n minus ones. Okay, greater than or equal to I into k. Okay, and if you solve this further, you will get nothing but I is greater than or equal to CL of ones by n minus k. Okay, so again, you can just simply code this out. But what will be the condition for this? What will be the condition for this? You saw that the condition for this is nothing but zeros module 2 equal to 0. But yeah, if you see, our condition was something like this. I into k module 2 should be equals to zeros module 2. Okay, the parity of both of them must be same. Now if it is told that I is odd, okay, then k retains its parity if I is odd. then I hope you do understand K retains its parity. Okay. K retains its parity. So it is essentially K in K module 2 should be equal to zeros module 2. So again, and I hope this is only sufficient condition. If you just write a statement, if this is true, then this inequality must hold. And if I is odd, then this inequality must hold. If I is even, this inequality must hold. And this inequality should always hold. Okay, so these three inequalities we have, we will just try to write them on code. Okay, and I hope this will work just fine. Mm, and some base cases are also there which are very easy to see, so while writing we will all just take care of those. So let's quickly try to code it out. We have n, which is nothing but s dot size. We also have value zeros. Okay, we initialize it to 0. And for now I just go through all the strings. If uh, p is equals to 0, I will just increment the zeros count. Okay, this much is very simple. I just count the number of zeros. And now what are the things which I will do? I will write some base cases. See, I want to convert to all ones, right? So if zeros is already 0, return 0, because in 0 number of operations you can just do that. Again, there can be another case where the number of operations which you want to do is equal to the k. So k is equal to n. So in one operation, the length you want to select, that is the whole length of the string. And then what will happen? Then if you might be thinking that return -1 for this, but no. So basically, you do understand what I'm trying to say, right? You have a string, and every time you want to flip the whole string. So you have this string. Every time you want to flip the whole string. So you will never be able to get all ones, right? But you will be able to get all ones if all were zeros. Okay. So this means flip the whole string. Okay. And if zeros is equals to n, then return 1. In one operation you can convert all to ones, else you just return -1. Okay, if all zeros, then one operation, otherwise not possible. Okay, I hope you do get what I'm trying to do. And yeah, and we can return to our inequality things. You see, you want this statement to be always true. I greater than equal to zeros by k. Okay, so zeros by k, we also have ones. So once I will have an variable ones, which is nothing but n minus zeros. I hope this is very clear. And what I will do next is have this condition. So I should always be greater than zeros by k. So some requirement, which is ceil value of ceil division. So I will write a function ceil division. Okay, and which will do nothing but zeros by k, which will take two arguments and calculate this thing, division operation of ceil. So just so that I don't forget, this is the criteria which was coming, zeros by k. Okay, I need to make sure that this is greater than equal to. So some requirement I keep. Okay, and now let's take the cases when I is even and when I is odd. Okay, so when I is even, zeros should also be even. So if I is even, okay, so if so I am just calculating this. This tells us the possibility that, hey, even value of I is possible. Okay, even value of I is possible. So zeros module 2 equal to 0. and even I, okay. Even value of I is nothing but, see, this inequality is there, which is nothing but ceil of zeros by n minus k. So let me write it, ceil d of zeros by n minus k. But you must remember, this inequality should also satisfy this requirement, and if there are two inequalities, I greater than or equal to a2, a1 and a2, then you take the maximum among them, right? So you take the maximum int mm, let me write here only maximum of requirement, this and this, okay. I hope this is also quite okay for you. And see, we will calculate two cases where I is even and when I is odd, and I will just have an answer variable, okay. Yeah, I want the minimum, right? So I will initialize by int max, and I will just get the minimum each time. Answer equals to minimum among answer and this even I, okay. So yeah, we will do like this. uh, if again for I is odd, I already explained what are the conditions. For I being odd, you have k module 2 equals to 0 module 2. So if I is odd, this possibility is true when k module 2 equals to uh, zeros module 2, right? Okay. If these two parities are equal, then an odd I is possible. Odd I is possible, and that will also be nothing but maximum of requirement and CL value of 1 by n minus k. This equation we just now derived. And again, I will just calculate the answer equals to minimum. So I find what is the what is the operations possible when I is odd, what is the operations possible when minimum operations possible when I is even, maximum. So and I will take the minimum of both of them because I want to return answer, right? Now I also may be returning -1, so I can write if answer is equals to int max, okay. Then you do return -1, right? If it is not still modified, else you can return answer. I hope. Yeah. So minimum of answer comma odd I. Now, do you think this will work? This will work. You see one thing, we are missing out something. This tells you the even value of I, right? But can this be odd? See, this tells you that the possibility that I is even, we are calculating the possibilities when I is even. And here also, which tells you that we are calculating the possibilities when I is odd, whether it is possible at all or not. And this tells you the operations. It tells you the total number of flips, okay, of it, of the total I being odd and total I being even, okay. But this may turn out to be odd also. In that case, we need to make sure that it is even. Otherwise, our assumptions will all hold wrong. So if you see this even I module 2 is, if you see something like this, then you do even I plus plus. Did you understand what I'm trying to do? If in case you see that this is coming out, we all consider that this is possible when I is even, right? But this is true doesn't mean that I is always even, right? And this, if this gives you an odd number, then just make it even. Again, you just tell this same thing. If this gives you an even number, okay, just make it odd. I hope you do understand about this. And that's all. I hope we are good to go. Try to run it and check if it works, or we need to do some debugging. yeah, we did not implement the cld function. Okay, so one function we will just simply implement, uh, cld, and I hope you know how to calculate the ceil of a and b. If both are integers, you just return mm, a plus b minus 1 by b. Okay, so that's how ceil value is calculated. If you don't know, you can just quickly Google this out. Yeah, and why it is done. So yeah, this is how ceil value is done. Using intuition also you can easily understand this. And yeah, so am I doing some mistake in syntax over here? Yes, so you see we got the accepted thing. If you try to run it for all cases, I hope it will work just fine. And the complexity is just O of n. You see, whenever you do this, you just iterated O of n for counting the number of zeros. All other operations are just O of 1. So just because of this, your operation is time complexity is O of n, and space complexity is O of 1 because you did not use any kind of arrays or anything to store. So yeah, I hope you did understand this problem. You also get a decent runtime complexity. So that's all for this video. If you have any kind of doubt, you can definitely ask me in the comment section. uh, I will meet you in the next video. Till then, thanks a lot.